Good morning, students. So today's practical is reverse bias of silicon junction diode. Here, as per shown, here the resistance is connected and diode in a reverse bias mode is connected. To measure the particular current flowing through the resistance and the diode is measured with the ammeters, and the voltage difference across the diode is measured by voltmeter. Here is the DC voltage source that we are attached in a particular combination. So first we set the particular diode combinations. There are different diodes are available, so according to requirement this could be used. Generally we used 1N4004. This is normal rectifier diode. This is also rectifier, but current limitations is different value, so I am choose the particular 1N4004, which is applicable to directly 30 volt. So DC voltage that you applied, that will be controlled from this level, and the resistance that you required, that will be covered in a particular. So if I move this slider, then you could be find that resistance value is varying. That varying resistor value is in ohm range, while DC voltage is in a particular DC voltage, that means constant. So you could be change the particular voltage. So here the resistance VR, that is resistance of the diode, is 30 ohms, and DC volt is, I make it out, the 7.5 volt. Generally we could change this to 5 volt. Okay, 5.8 volt, then 5.85, then 5, and then such a things is going to be changed. So we are started with the point fractional value. So we change resistance, we put it down, that is 600 ohms, so 650 ohms, that is going to indicate out. So if we make this, then add to button, add to table. So you could add the first reading, that is you are supplied the 0.170 volt, which is directly given 0.0110. So up to this point we are measure the one, and second reading I am going to be take to with 1.3 volt, then I am measured, so that is again, then I am covered with the 3.85, then this is 3.65, this is 5.98, this I make it out 7.62. so you could find there is current is constant. So up to which point constant? So let's we see at what distance it is become a constant. 100 milliamps, then once again voltage change, that is 100 milliamps, and then I'm added with 100 milliamps, then add 20 is also 100 milliamps, then it's added with 26.6 milliamps, then increase with that is give it out 100 milliamps, and up to near about 30 volt if I'm added, you could be find there is massive amount of current flowing within a circuit. And if we plot this, so you could be have the plot like this. So if we comes with the inverted, then this plot it directly in a quadrant based environment. This is the button for printing the environment. This is simulation part, and using that simulation part it is acceptable in a each and every composition. So you could be fine, this we have to perform in our lab. So in that lab environment, this voltage is almost a 6 volt. So there is no more than 6 voltage we applied, but as this is simulations, you could be directly applied the particular combinations in a particular notation. So you could be find there is a constant current flowing, and at a one particular point the junction breaks, and junction breaks delivered the massive amount of current flow at a 30 volt. So this become a regulator for 30.4 volt. So that is give it out here. Here we are taken the readings at a random level, but when we perform these practicals in a sequential lab environment, then we are changing from 0.1 multiple of 0.1, or it's a 1 volt, 2 volt, 3 volt. So maximum breakdown voltage of the Zener diode is directly make it out with the 1 volt or 1.2 volt or 3 volt or 3.5 volt. Why? Always it is point fractional. This point fractional voltage is we take due to the leakage current property. So this is practical 1.